Hello students, Mr. Madison here with another instructional video for you. This is the third in a series of instructional videos, all dealing with the area of circles and or the area of parts of circles. To this point, we've talked about finding the area of a circle, and we've done application problems involving finding the area of a circle. We've also learned how to find the area of a sector. In today's lesson, we are going to learn how to find the area of a figure that is just commonly referred to as a ring. So to be certain that everybody knows what our goal is, I'll just write it out up here. Our objective for today is that by the end of this lesson, everyone will be able to find the area of a ring and part of a ring. And I will explain and demonstrate through probably a half a dozen or so examples. You'll probably be thrilled to hear this will not be a long instructional video. So first thing we need to do is make sure we understand what a ring is. A ring is an area that is bounded by two circles. Bounded by two circles. It is, if you will, very simply described as one circle inside of another circle. But bounded by two circles is what is how you would define a ring, bounded by two circles. So I've drawn some diagrams here to facilitate my demonstration. And we're looking at this diagram right here. And I want to shade in the part of the diagram that would be the ring. So this part of the diagram that I am shading would be considered a ring. So its outer bound is that big circle, and its inner bound is the small circle. One way to think about a ring is to think about taking a big circle, say the big circle here, and removing or cutting out the small circle. And you would get, if you wanted to describe this in terms of objects from the world around us, you could think of a donut, you can think of a tire, you could think of a ring. I think calling this a ring is probably a pretty good name for it. And what we want to do is we want to be able to find the area of this ring. To find the area of a ring, all you're going to do is a subtraction problem. The area of a ring, this is the formula that I'm giving you for the area of a ring, is just the area of the big circle. So I'm just going to put subscript big circle, and then you subtract the area of the little circle. So it's, if you would cut out the little circle from the big circle, what's left is the ring. So that's why we have this formula. It's big circle minus little circle. Simple as that. So let me do some examples for you. But this is going to be what we're going to go to as we do all of these problems. We're just going to rely on our formula. And the formula for the area of a ring is the area of the big circle minus the area of the little circle. So here's what I'm going to do. So let's say this is the center of both circles. And I'm going to draw in a radius of the big circle. And I'm going to tell you that this distance here is, let's say that's 8. And then this distance here, make sure you understand the distance that I'm alluding to. I'm talking about this distance from the outside of the little circle to the outside of the big circle. We'll say that is 5. So we're going to plug into our formula. We're going to find the area of the shaded region here. SR still stands for shaded region. It's just that in this problem, the shaded region is a ring. And that's going to equal the area of the big circle. Now, if there is anything that would be considered tricky about this problem, it is this. When you go to find the area of the big circle, to get the radius, you're going to have to add the 8 and the 5 together. So the radius of the big circle is actually 13. And don't forget, the area for a circle is pi r squared. So we're going to use this formula for the area of a circle as we're finding the area of the ring. So the area of the big circle would be pi times the radius, which is 13 squared. Then we need to subtract the area of the small circle. So that would be pi times the radius of the small circle, which is 8 squared. Now, when we get our answer here, we're going to find our answer in terms of pi. So we're going to have a pi in our answer. So 13 squared is 169. So it'd be 169 pi is the area of the large circle. And then the area of the small circle would be 64 pi. And 169 pi minus 64 pi is going to be 105 pi. Now, if I assign units to this 8 and this 5, if I tell you it's 8 inches and 5 inches, then when you find the area here, it's going to be 105 pi square inches. And that would be the answer to this first example problem. Let me make up another problem here. Here's the center here. I'm going to draw a radius for the big circle. I'm going to tell you that this distance, which is the radius of the little circle, is 10. And then this distance here is, let's say, 4. And I want to find the area of the shaded region. I'm going to go ahead and shade it in. And the shaded region is, of course, a ring. So to find the area of the shaded region, we'll be finding the area of a ring. And to find the area of a ring, we find the area of the big circle, we find the area of the small circle, and we do a little subtraction problem. So here we go. The area of the shaded region is going to equal the area of the big circle minus the area of the little circle. The area of the big circle is going to be pi times its radius squared. Understand that the radius of the big circle is 14 minus the area of the little circle, which would be pi times 10 squared. So that gives us 196 pi minus 100 pi. And then our answer is going to be 96 pi. And again, if this is inches for our units, then this would be square inches for our area. All right. Let's make a problem out of this here. Let's suppose that I come in and I draw in a diameter. And this is the center here. And I tell you that the radius of this small circle is, let's say, 7. And the radius, not the radius, but the distance from the outside edge of the small circle to the outside edge of the big circle is just 2. Now watch what I'm going to shade here. I'm going to shade this part of the diagram. And I'm going to stop right there. And we're going to be asked to find the area of the shaded region. So this part that I shaded, obviously, is not the entire ring. It's just half of the ring. So this part of our objective is what we're looking at right now. We want to be able to find the area of a ring, and these first two problems, that's exactly what we did. But in this problem, we're finding the area of part of a ring. This part that I shaded would be half of the ring. So when I go to find the area of the shaded region, I'm going to find the area of the ring, but I'm only going to take half of it. So it's going to be 1/2 times the area of the big circle minus the little circle. So here we go. It's going to be 1/2, and I'm going to go ahead and find the area of the ring and then just multiply by 1/2. So the area of the big circle would be pi, and the radius is 9, and we square it. Again, the 9 is coming from adding the 2 and the 7 together, minus the area of the little circle, which would be pi times 7 squared. So that gives me 1/2, and I'm going to have 81 pi minus 49 pi. And that would be 1/2. Let's see, 81 minus 49 would be 32 pi. And half of 32 pi would be 16 pi. And we're home. Let's run through this problem. In this problem, we are not finding the area of the entire ring. We're just finding part of it, or exactly half of it. So we go ahead, and in the parentheses here, the parentheses represents the area of the ring. So I figured that out. It turned out to be 32 pi. If this question had the entire ring shaded, our answer would be 32 pi. But it's only half shaded, so it's going to be 16 pi. Let's look at this problem. I'll make this up as we go here. I'm going to draw in a radius. I'm going to draw in another radius here. And I'm going to say that this central angle that I just created is 72 degrees. Now let's say that this distance from here to here is 10. And this distance from here to here is 10. And I'm going to shade, again, not the entire ring, but just part of the ring. This is the part of the ring I'm going to shade right here. Now, just like when we were finding arc length, and just like when we were finding the area of the sectors, we get involved with determining what fraction of the entire circle is being shaded in. We only want to find the area of part of this ring. The area of the entire ring would be big circle minus little circle, but we just want a fraction of that. So understand, in this problem, the area of the shaded region is going to equal some fraction times the area of the whole ring. The fraction is determined by taking the degree measure of that angle and dividing by 360. Now, just very quickly, 72 over 360 would reducify down into 1/5. What that means is that the part that's shaded here is 1/5 of the ring. And then I'm going to multiply that 1/5 times the area of the entire ring, which would be the big circle, pi, times its radius squared, so that'd be 20 squared. 10 plus 10 gives you the 20, minus the area of the small circle, which would be pi times 10 squared. So I'm going to go ahead and change the 72 over 360 to 1/5. And then inside my parentheses here, the area of the big circle would be 400 pi. The area of the small circle would be 100 pi. So this gives me 1/5 times 300 pi. And 1/5 of 300 would be 60 pi. If these are inches, then this would be square inches. And that's my answer to this example problem. So just to review this very quickly, in this problem, we are finding the area of just part of the ring. Whenever you find the area of part of the ring, you're going to be multiplying a fraction times the area of the entire ring. To determine the fraction, you take the degree measure of that central angle and divide it by 360. In this case, it turned out to be 1/5. So our area here that's shaded is 1/5 of the area of the entire ring. Let's do 2 more problems. Let's see. I'm going to draw in a radius here. And let's say that this distance here is 10 inches. And this distance here is 20 inches. And let's see, I'm going to make an angle here, a central angle, and I'm going to tell you that that's a 108-degree central angle, and I'm going to shade part of the ring. I'm going to shade this part of the ring right here. And our job is going to be to find the area of this shaded part of the figure. So when we go to find the area of the shaded part of the circle, we realize that we're not finding the area of the entire ring. We're just finding the area of part of the ring. So the area of the shaded region here is going to be some fraction times the area of the entire ring. To determine the fraction, you take the degree measure of the central angle, so that would be 108, divide it by 360. And I'm going to multiply by the area of the entire ring, which would be big circle minus little circle. The area of the big circle would be pi times its radius squared, and the radius is the distance from the center to the outside edge. So it's going to be 10 plus 20 would be 30 squared. And we need to subtract then the area of the small circle, which would be pi times 10 squared. Now, you can leave 108 over 360 and just enter that into your calculator. If I reduce that, however, I think I'm going to come up with 3/10. And again, you don't have to take that fraction and reduce it at this point. You can. And this would give me 900 pi minus 100 pi. So in the very end here, I'm going to be trying to figure out what 3/10 of 800 pi is. Understand that this 800 pi represents the area of the entire ring, but we just want 3/10 of that. So let's see, 10 goes into 10 once, 10 goes into 880 times, and 3 times 80 would be 240 pi, and it's going to be square inches. Okay, one more problem to do. Let's see. I will draw in a central angle. And let's say that we make this central angle 60 degrees here. And we'll say that this distance, which is the radius of the small circle, is 12 inches. And this distance here, we'll say is 6 inches. Now, look what I'm going to shade, however. I'm going to shade this part of the diagram here. And the question's going to be, what part of the entire ring am I shading? And of course, we're going to have to go back to looking at that 60-degree angle. But notice that I am not shading a 60-degree part of the ring. I am shading the remainder of the ring. So when I determine the fractional part of the ring that's shaded, I'm not going to use 60. Instead, I'm going to use 300. So just to be sure you're following, if it's 60 degrees from, say, here to here, then it has to be 300 degrees all the way around. So the area of the shaded region here, and the shaded region is a partial ring. It's going to be some fraction multiplied by the area of the entire ring. The fraction in this case is determined by taking 300 and dividing by 360. The 300 is the degree measure of the arc from here all the way around to here. Then I'm going to multiply by the area of the ring, which would be big circle. So that'd be pi times, and the radius of the big circle is 18 squared, minus the area of the little circle. So that'd be pi times 12 squared. All right, now I'm going to go ahead and reducify this fraction. This will reduce to 5/6. Once again, don't let that be anything that trips you up. You can leave 300 over 360 and then do this problem on your calculator. And then inside here, I see that would be 324 pi minus 144 pi. And I'm going to have 5/6. And let's see, 324 minus 144. I think that's going to be, let's see, 0, 280. Is that right? 180. Let's make sure I'm doing my arithmetic right. Don't want to blow it at the end here. So I'm doing 324 minus 144. I'm coming up with one. This is a 180 pi. And then the 180 pi actually is the area of the entire ring. But the entire ring is not shaded. Just 5/6 of it is shaded. So I need to multiply 5/6 times 180 pi. Let's see, 6 goes once, and 6 goes 30 times. And 5 times 30 would be 150 pi square inches. And that's the answer to this problem. So, by way of review, our objective today was to be able to find the area of a ring and parts of a ring. And we did 6 example problems demonstrating how to do that. The area of a ring is determined by finding the area of the big circle, finding the area of the little circle, and then just doing a subtraction problem. If it's part of a ring, you're still going to find the area of the big circle and subtract the area of the little circle. But then you have to multiply by some fraction. And that fraction will always be determined by the degree measure of that central angle. In this problem right here that I'm gesturing to, this ring right here is a 72-degree ring, which reduces down to 1/5 of the whole ring. And then in this problem, the 108 reduced down to 3/10. So the shaded part is 3/10 of the whole ring. And then in this last problem, and we've had situations like this before, we're given the 60, but the 60-degree ring is not shaded. The 300-degree ring is shaded, which corresponds to 5/6 of the ring. So there you have it. That's how you find the area of a ring. I hope you're able to follow. You can expect a practice sheet that asks you to do problems just like I've demonstrated here. Thank you, students, for your attention. You all have a great day.